Okay, I'm working on 10.6, which is cylinders and quadratic surfaces. I'm doing numbers 21 through 27 in the book. So starting out with number 21, we're given the equation y squared equals x squared plus 1/9 z squared. And we're supposed to reduce the equation to one of the standard forms and classify the surface. So first thing I'd like to do is see if it's possible for me to match this up with one of the forms of quadratic surfaces on page 578. So do we ever have one of the variables squared on one side and the other two variables squared on the other? And that looks kind of like a cone, okay? So the standard form of a cone, since this is the first problem, I'll go through this a little slower. The standard form of a cone is z squared over c squared equals x squared over a squared plus y squared over b squared. And this would be a cone that would open up the z-axis. So it goes up the z-axis, down the z-axis. And that's because this is the variable that's isolated. Now over here, the variable that's isolated is y. So we're going to have the same sort of idea here, except our cone should go out the y-axis instead. Let's just identify the constants on the bottom. So this is the same as y squared over 1 squared equals x squared over 1 squared plus z squared over 9 squared. So this would be a cone. And I'll add on here, it opens out the y-axis. So it doesn't ask us to sketch this. Our vertex would be the point 0, 0, 0. So if you plug in 0, 0, 0 for x, y, z, you get a solution to the equation. So we know it goes through the origin. So if I were to try and draw this, and this might be a disaster here, right? I could say it. It's here, and then let me just go out the y-axis here. Let's pick some x. Let's pick a y value here. Let's let y be 1. So let's see what happens at 1. Remember, this is our y, this is our x, this is our z. So if y is 1, I've already answered the question. Its cone opens out the y-axis. But I'm trying to get an idea of how I would draw this. So if y is equal to 1, then the left side of this equation becomes 1 equals x squared plus z squared over 9. And then that, from previous classes, would be an ellipse. And so let's try and imagine we've moved out y equals 1, and we're out here. And imagine that, there's a plane here, right? That's the xz plane has been shifted out 1. So what would we draw on that? So let's just pick a value. If x is 0, right? If x is 0, then this equation becomes 1 equals z squared over 9, which is 9 equals z squared, which means plus or minus 3 equals z. So if I go out, y is 1, put me here, x is 0, which means I don't move left or right here. I would have a point up 3, so 1, 2, 3, okay, and a point down 3, so let's say it's 1, 2, 3, and then a point down 3, 1, 2, 3, like this, okay? Then let me try something different. Let me try, instead of this, z is 0. If z is 0, what would happen? We'll go up here, and we get 1 equals x squared. So plus or minus 1 equals x. So if instead I go out and y is 1, z is 0, so I don't go up or down, then I go left and right 1. So see, to the left one would be here, to the right one would be here. And now what I can do is I can connect these together. With an ellipse like this. Okay? Now if I do the opposite side, and I would have done y is -1, the whole thing would have been exactly the same. So if I would have come out -1 on y, then I would have gone up 3, would have gone down 3, would have gone left 1, right 1, and then I would have drawn my ellipse over here like this. This. And then I know it goes through the origin. So connect this, 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 and that. Okay. So we got this cone. It's kind of hard to see this, but this cone that opens up out the y-axis and then out the z-axis. All right, let's do number 22. Four x squared minus y squared, or sorry, minus y, plus 2z squared equals 0. So again, I'm going to be looking on page 578, trying to match up what looks like it would go best with this. So notice I have two variables that are squared and one of them which is not. So I can rule out an ellipsoid, I can rule out a cone, I can rule out hyperboloid 1 sheet, I can rule out hyperboloid 2 sheets. Might be an elliptic paraboloid or it might be a hyperbolic paraboloid. So let's see, let's try and isolate this variable. So I'm going to write it this way: y equals 4x squared plus 2z squared, like that. And I'm thinking it looks like an elliptic paraboloid, which is a z over 6 equals x squared over a squared plus y squared over b squared. So notice I get the two variables that are squared on one side and there's addition between them, which is what I have here. I have a variable that's not squared on the other side. So I just need to figure out what these constants are below these things. So I'm going to rewrite this as y over 1 equals x squared over 1/4 plus z squared over 1/2. So that's just using the fact that 4 is the same as 1 over a fourth, 2 is the same as 1 over a half. And then I can rewrite this as y over 1 equals x squared over, now this is like the a squared, so I'm going to put 1/2 squared and then plus over here z squared over, and then this will be 1 over root 2 squared. So I've identified these letters basically, the numbers underneath those. So that is going to be an elliptic paraboloid. Elliptic paraboloid. Now, in this particular case, well, in this one over here, it would look like this. It would go up the z-axis, like a bowl going up the z-axis, because the z is the variable that is not squared. So over here, what we should have is something that looks like this. if this is the y-axis, it should look like, it should come out to the right like this, like that. So I guess on this one, I'll draw the picture again just to show you. I may not do it after this. If I were going to try and draw this, let me work with that one down there. What I could do is like first see if the origin is a point. Well, 0, 0, 0 is there, so this point does exist on the graph. And then I can try replacing y with something. So, you know, I think I'll rewrite this problem as it was in the beginning. Might be easier to work with. So let's replace y with 1. So if y is, y is 1, that means we'd be out on the y-axis right here at 1. And what would happen? Well, we would get this. We get 1 equals 4x squared plus 2z squared. And then I'd rewrite that as 1 over x squared over 1/4 plus z squared over, I'm back to where I was earlier. But this is an ellipse. So what we could do here is we could pick some values, like let's just let z be 0. If z is 0, then this is going to become just this equation, and that'll become 1/4 equals x squared if you do the algebra there. So plus or minus 1/2 is x. So let's see, y was 1, z was 0, so I don't go up or down. My left and right is 1/2. So let's say this is 1. 1/2 would be here, so something like this, and then over here, like that. And then I could try something else, like x is 0, and rewrite this, and I get 1 equals 2z squared, and that means 1 over root 2 plus or minus equals z. And so, in fact, this number is a little bigger than that number, so I'm going to go up a little bit bigger, down a little bit bigger, and then connect together. I get this ellipse, like that. If you want to look at it a different way, if z is 0, right? If z is 0, this is a parabola, right? If x is 0, this is a parabola. So we have parabolas opening up like this, and then also through there, like that. But let me point something out here. If you try and let y be -1, it's impossible to get a solution, because this side cannot be negative when you're taking two things that are being squared, multiplying them by positive numbers and adding them together. There's no way you can make that -1. So it's impossible for me to have any points over here, which is why this thing only opens up one way. So, okay, that's good enough. 23. So 23, x squared plus 2y minus 2z squared equals 0. This is very much like the last problem, but when I try and isolate the y, let's see, 2z squared minus x squared. So I'm just moving things around here, bringing this one and this one to the other side. Let me divide through by 2. So this looks a lot like the formula hyperbolic paraboloid. This is the formula for hyperbolic paraboloid. Z over c equals x squared over a squared minus y squared over b squared. So notice you've got two variables that are squared, one that's not. You've got subtraction between these two. And so this is definitely going to be a hyperbolic paraboloid. And I won't go through and try and draw it. That would be a hard one to draw. Really not a lot in this section as far as the homework is concerned. 24. So for 24, you've got y squared equals x squared plus 4z squared plus 4. So we have all three variables squared. One of them is isolated on one side. The other one, it has addition between these. So this is looking a lot like the cone again, except we also have a number. That's different. So if it were this, it would be the cone, but we have a number also. So what we need to do is see if we can get this to basically become a 1. So let me move the x squared over. I'll make it negative x squared plus y squared plus 4z squared, I'm sorry, minus 4z squared equals 4. So I've just moved these two over to this side, which made them both negative. I'm going to try and make this a 1, so I'm going to divide everything by 4. Negative x squared over 4 plus y squared over 1, really. Oh, no, I divided by 4, sorry. And then minus z squared equals 1. So in looking at these, if you look at the hyperboloid of two sheets, you'll notice that you have two of your variables squared that are both negative. One of your squared variables is positive, right? And then you have a 1 on the other side. This is the format of a hyperboloid of two sheets. There you go. And let me see. It actually, because the y is the positive one, if we were to draw this, it would go down the y-axis. So it's like this bowl over here. You know, it's hard to see this. It's kind of like this bowl. It's opening up this way, and then there's a bowl on this end that's opening up that way. So two bowls, opposite directions. All right, 25. I think this will be the last one I do because the next two are just like number 25. So all of these that we've done, it's pretty clear what's going on because you can match it up to a formula. 25 is the first one where we have to actually do some work first. So for 25, I have 4x squared plus y squared plus 4z squared minus 4y minus 24z plus 36 equals 0. So for the first time, we have not only squared variables, but then we also have some of those variables, more than one of them, appearing as linear terms. So what we're going to do is we're going to try and complete the square. So 4x squared, I don't have any x terms, just x squared. And then plus, let's see, y squared, but then I have minus 4y. Plus 4z squared, but then I have minus 24z. And then plus 36 equals 0. All right, so that's where I am so far. I do not need to complete the square on this one. 4x squared, that's fine. On this right here, since I have a leading coefficient of 1 here on the y, I can take half of this, which is negative 2. I square it, which is 4. I'm going to add and subtract it right here. So y squared minus 4y. I'm going to add 4, subtract 4. And then on this one, these two, I have to pull a 4 out first. Remember, I have to factor before I can complete the square. All right, so now I'll complete the square on this. And I have to do it inside that parentheses. While I'm at that, I think what I'll do is I'll go ahead and put those together. We know that that's going to become y minus 2 squared, but then we still have minus 4. I think I'll put the minus 4 together with the 36 and just make it a 32 at the end. So here I'll put the 32 at the end. And here I've got my 4, and then in here I'm going to take half of negative 6, which is negative 3, square it, which is 9, add and subtract it. So z squared minus 6z, here's my plus 9 minus 9, close parentheses, plus 32. Now, this becomes, sorry, this is all equal. Oh wait, no, there was an equation. So this just becomes this, and then this. So this is 4x squared plus y minus 2 squared. Then I have a 4, so plus 4. And then this right here, these three, become z minus 3 squared. But then I still have in here minus 9. So that 4 is going to have to pass through. And then plus 32 equals 0. So this becomes 4x squared plus y minus 2 squared plus, let's distribute the 4 to this, which just becomes 4 in front of that parentheses. And then 4 to here, we get negative 36. And then plus 32 equals 0. And when I put these two together, I get negative 4 and then move it to the other side. So I have 4 equals, and then this is like 4 times x minus 0 squared, that's the same as x squared, plus y minus 2 squared, plus 4 times z minus 3 squared. All right, so now we're getting somewhere. This looks a lot like we've got 3 variables in here, x, it's being squared, plus the y being squared, plus the z being squared. So which equation do I have where I have all 3 variables squared, and then equals over here, let's see, 4, I can make that maybe a 1. So it's looking pretty promising, like this is going to be an ellipsoid. Ellipsoid has the form x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. So we have all 3 variables squared, and then numbers underneath, which I can do, and then this side 1. So the key is that they're all positive, and that I have a 1 on the other side. So let me turn that into a 1. So I'm going to divide everything by 4. So divide this by 4, divide this by 4, divide this by 4, divide this by 4. And so I get, this is just x squared, but I'm going to leave it as x minus 0 squared. You'll see why. Plus, this is going to be y minus 2 squared over 4. These cancel, so plus z minus 3 squared over 4, no, 4, not over 4. Canceled it out. And then equals 1. So this is definitely an ellipsoid, all right? It's an ellipsoid. Okay, but the center of the ellipsoid has been changed, all right? The center I'm going to grab from these numbers, 0. Well, remember you take the opposite of this, so 0, opposite of negative 2 is 2, and then the opposite of negative 3 is 3. So it's an ellipsoid centered at 0, 2, 3. So remember, in this formula, it's really x minus 0 squared, y minus 0 squared, z minus 0 squared. So if I put some numbers in there, like I do have here, then all it's going to do is move the center of that ellipsoid. So it just moves the whole thing. That's it. All right, so that was number 25. I'll just tell you what 26 is. 26 is an elliptic paraboloid, and the vertex of that, which is going to be the bottom of the bowl, is the point 022. And for 27, it's going to be a cone, circular cone, with the center 2, -1, 1.